Moving away platinum is a very important necessity for the sovereignty of Europe in the deployment of green hydrogen. Indeed, very limited countries have platinum, Russia, South Africa, for example, so that means the deployment of hydrogen in Europe will be dependent on those countries. On the other hand, nickel resources are much broad in many countries, such as Australia, New Caledonia, and so that means with a more affordable and sustainable resources, the deployment of hydrogen, green hydrogen, will be much more easier for Europe. Nickel tungsten alloys with some phosphorus as a dopant are supposed to have the same electronic structure as a platinum. Doing so, we suppose that with the nickel tungsten alloys, the absorption energy of the intermediate of the hydrogen evolution reaction would be the same as on the platinum, and so to have at the end the same activity. But the point is the number of active sites on nickel electrode are much lower than on the platinum. So to have the same activity on nickel-based electrode, much more loading of nickel are needed. So to make a nickel-based electrode as active as a platinum, this task is really challenging, and so a lot of work are still required and will be needed for the future. In a real industrial world, the main target is to reduce the levelized cost of hydrogen LCOH at the lowest value as possible. So for sure, if we replace platinum with the nickel, the cost for the MEA will be reduced drastically. But if the electrode made with the nickel is much less active than the platinum, so most probably more MEA will be needed, and so at the end the stack cost could be higher. So, a more accurate evaluation of the replacement of platinum with nickel is needed in order to estimate if the the lower activity of nickel is somehow balanced with the lower investment cost. The major milestone for the deployment of electrolysers powered with the NICKEFFECT technology is to improve the activity and also the stability of those electrodes. We have seen at the end of the NICKEFFECT project that the electrode prepared with the electrodeposited nickel have some activity for hydrogen evolution reaction as a cathode of PEM water electrolysis. However, the performance was still well below in comparison with the platinum. Also, we also have seen some stability issue when the electrode were in contact with the acidic media, such as the PFSA membrane of PEM water electrolysis cell. So these two challenges are still remaining, and much more studies are still needed to overcome these two drawbacks: improve the activity and also improve the stability in the acidic media.